Listen up, mathematicians, it's number code. On this week's episode, we'll be learning about probability. Hey Sam, what are you doing?
Fishing for probability.
Alright, some rules for general probability. First would be that the total probabilities of all the events will have to be equal to 1, and no probability can be negative.
So one time I bought a brownie for Mrs. Dewey thinking like maybe she'd give me like extra homework points or something. Yeah, she didn't. So long story short, never doing that again.
Hey Robert, want to play a game? What's this game about? Close your eyes and pick the red ball out of my net. The probability of me picking the red ball is 1 out of 4. How do you know that, Robert? Well, there are 4 total balls, but there's only 1 red ball, so the chances of me winning aren't very high. So you don't want to play?
When people don't format right on Trickstar packets, like, what's the point? You ain't gonna get no points. I can't.
2 independent events are 2 events whose occurrences do not affect each other.
Hey there, Sam.
Is this the number devil?
It is. Are you ready to learn something fun new today?
Yeah.
Okay, how many balls are in that net you're holding?
4.
Alright, and what's the probability of picking a red one out?
1 out of 4.
What's the probability of picking a yellow one out?
3 out of 4.
Alright, now stick your hand in and pull out 1 ball. Alright, now you only pulled out 1 yellow one, so what does that mean? It means that since you're only pulling out 1 ball, that you can't pull out a yellow one and a red one at the same time.
Wow.
You want to know what it's called?
What's it called?
It's called mutually exclusive events, where 2 events cannot happen at the same time. As in the example here, pulling a red ball and pulling a yellow ball. That's it.
If you want to find the probability of A or B, find the probability of A plus the probability of B minus any reoccurring events.
I sleep with my calculator. Is that weird? If the occurrence of one event affects the occurrence of another event, then the events are dependent.
Hey Sam and Roberta, are you ready to learn a little bit more about probability?
Yeah!
Alright, we're going to look at this example. There are 6 red marbles and 10 blue marbles in the box. 3 marbles are selected without replacement.
Yeah, what's without replacement, Robert?
Well, we have a box, and let's say we were to take out a red marble, and then we go to choose another one. We would not replace the first red marble, and that's without replacement.
Oh.
We're going to look at number 1. What is the probability that all 3 marbles are red? So to figure this out, we look at the total number of marbles in the box, which is 16, and the total number of red marbles, which is 6. So for our first pick, the probability of getting a red marble is 6 out of 16. Now for our second pick, there are now going to be a total of, because we're not replacing that, 15. So 15 goes in the bottom, and now there are only 1, 2, 3, 4, 5 red marbles. So 5 goes on the top. And for the third and final pick, there are now a total of, how many marbles in the box? Think. 14. 14, correct. And how many red marbles are there now, Roberta? 4. Okay. Now to find the probability that all 3 marbles are red, we multiply this together to get 1 out of 28. So the probability